Hey guys, Mr. Longbreak here again, and this is our last lesson of the entire school year. So congratulations, you've made it to the end. And this lesson is focused on the third and final factor or stress that can be placed on a reaction at equilibrium, and that is pressure slash volume, and both are going to be kind of the same concept. Now, first thing, let's talk about what pressure and volume is. Again, you should know this, dating all the way back to our gas laws, but pressure is how many collisions the particles have with the sides of its container, and volume is the amount of space something occupies. Okay, so now that we remember what those two are, let's talk about how they can shift a reaction that's at equilibrium. Now, if you increase the pressure of something, which is the same as decreasing the volume, and just to make sure we remember that, if we look at these two particle diagrams here, this one would have a very small volume, this one would have a very large volume. This one would have a higher pressure because the particles are going to hit the sides of its container more often in that smaller space. This would have a lower pressure because those particles aren't going to collide with the sides of its container as much. So if you see something that says increase pressure, it is the same as saying you decrease the volume, or it's going to have the same effect. So if pressure is increased or volume is decreased, it's going to shift to the side with less moles. And in particular, moles of gas. If it's a solid or liquid or aqueous substance, then pressure or volume will not affect that particular reaction at equilibrium. So it has to be moles of gas. On the other hand, if there is a decrease in pressure, meaning that volume has been increased because at a higher volume pressure goes down, then it's going to shift to the side with more moles. And remember, it has to be moles of gas once again. Okay, so let's talk about why that makes sense. So let's use two particle diagrams. Let's say this is the reactant side, and let's say this is the product side. And let's say on the reactant side, there's 5 moles of gas, and let's say on the product side, there's 2 moles of gas. Okay, well, two things can happen. You can either increase the pressure or you can decrease the pressure. Well, if pressure is increased for this reaction, the reaction is going to find a way to decrease that pressure to reduce the effect of that stress. Well, in order to decrease pressure, it's going to shift to the side with less moles. And that's because less moles is less pressure, which will balance out that stress that was placed on the reaction. Less moles, less collisions, lower pressure. Now, on the other hand, if pressure were to decrease, then the reaction is going to shift in a way to increase that pressure. Well, which side of this reaction has more pressure? The side with more moles. More moles, more collisions, higher pressure. So if pressure were to be decreased of this particular reaction, it would shift to the side with more moles, which would lead to increasing that pressure back up. Okay, now if that is confusing to you, let's go ahead and look at these 3 examples to help clear that up. Okay, so example number 1, it says if pressure were to be reduced, and in other words, that means the pressure went down, which way will the reaction shift? Now, you always want to start with the number of moles of gas on each side of the equation. And if you forget how to identify that, it's based on the coefficients. And there are no coefficients in front of these substances, so we can assume that each of those coefficients is 1. So I'm going to count the total number of moles of gas on the reactant side, which is 1 plus 1 is 2 moles of gas. And the total amount of moles of gas on the product side, which is just 1 mole of gas. And notice that each of these subscripts are G, meaning they're all gases, And that is really important because if they're not, then pressure will not alter this particular reaction. Okay, so I have 2 moles of gas on the reactant side, 1 mole of gas on the product side. If pressure goes down, the reaction is going to try to find a way to increase that pressure back up. And the way it's going to increase that pressure back up is by shifting to the side with more moles. So the side with more moles in this particular reaction would be the left. So this reaction would shift left. All right, next example. If volume were to be decreased, which way will the reaction shift? Now this is important. If volume goes down, you can look up here if you need to send yourself a reminder. That means essentially that the pressure has been increased. And if the pressure has increased, the reaction is going to find a way to decrease that pressure. How does it decrease that pressure? By shifting to the side with less moles. So let's count our total moles here. On the left side, there's 1 plus 10, 11 moles of gas, and they are both gases. And on the product side, there is 3 plus 4 moles of gas, which is 7. So we said that since volume goes down and pressure's increased, that the reaction is going to shift to the side with less moles. The side with less moles in this reaction would be the right. So this reaction is going to shift right. Okay. Last, if volume is increased, which way will the reaction shift? Well, volume goes up. That is essentially saying that the pressure goes down. And if pressure goes down, the reaction is going to try to find a way to increase that pressure. So we're going to be shifting to the side with more moles of gas. So let's count the total moles on each side in this reaction. There's a total of 2 moles of gas on the reactant side, and then a total of 1 plus 1, 2 moles of gas on the product side. Well, if you look here, the number of moles on each side is the same. Therefore, there would be no shift in this particular example. And that's because the moles of gas are equal. Therefore, the pressure is equal on each side. So altering the pressure or volume in this particular reaction would create no shift. This is kind of a trick question. The other type of trick question you could get is if your subscripts are liquids or solids. Remember, it has to be moles of gas. And if it's not moles of gas, then altering pressure or volume would not shift the equilibrium in any way. So that wraps up all the material for Equilibrium Unit 11 and the entire year. Thanks for bearing with me, guys, throughout this really tough process and situation. Enjoy your summers. I miss you guys like crazy, and I'm sorry we couldn't have a proper goodbye. But please stop in and say hello next year. I'll be in the same exact room, and I'd be eager to see all you guys again. So enjoy. You guys have deserved this summer vacation more than any other. And I look forward to seeing you guys back at Scioto next year. All right, we'll talk to you later.